So if we had a situation like this, can I add those numbers together? Yes or no?
Yeah.
Why not? Can I add them like right now? I can't add them together.
Well, because they're both not in a fraction, so you have to do 3 times 3, and then.
So yeah, you're right. They're both not in a fraction. So we'll get to the how in a second. They got to have common denominators. So what Troy was saying is we're going to need 3 times 3 so that we get that same denominator there. That's great, Troy. Remember that 3 is just a fancy version of 1. The 3 over 3 is a fancy version of 1. So we're doing that exact same concept right here. So what does this cosine right there need to get multiplied by so that they have common denominators? Cosine over cosine, which is just a fancy way to say 1, right? So we're going to multiply by cosine over cosine. Try to see the parallels to just normal fraction work. Now there's just trigonomic functions in it. So we've got sine squared divided by cosine plus cosine squared over cosine. Okay. Now can I add them? Yes, I can. I get sine squared plus cosine squared on top. Does anybody remember what that becomes based off of yesterday? Just a big fat 1. Good job. So we will have a 1 divided by cosine x. That's actually at the bottom of your paper, by the way, if you didn't see it. Sine squared plus cosine squared is 1. So you're left with just 1 over cosine. Now, it's not on my math lab today, but if it was, they would probably want you to have a final answer of secant. Because remember, 1 over cosine is secant. By the way, I'll pause the video. So for number 2, can we add those together? Yes or no? Right now, can we add them? Not yet. So I'm multiplying by cosine over cosine. Great question, because when the denominators don't match like that, you have to take the other denominator, and that's what you choose to multiply by. So for this fraction, if I'm multiplying by cosine over cosine, what am I multiplying the other fraction by?
Sine over sine.
Sine over sine.
I can do that now. A lot. Most of the time. 50%.
That first purple fraction, we've got sine squared over sine x cosine x. The red fraction, we have cosine squared over sine x cosine x. Are we ready to add these? Yes or no? Yes, we can. What is sine squared plus cosine squared? Just a 1, okay? So you've got 1 over sine cosine, which again, I personally would rather have it in that form, but just so you're not thrown off later, final answer should probably be cosecant times secant. If you had something like this, now, before, if those got split into 2 fractions, what would the 2 fractions be right there? If you broke it apart into 2 fractions. 3 over 6 plus what? 3 over 6 plus 3 over 6, okay? We're going to do that exact same concept right there. So again, use that skill to tie it to using the trig stuff. What are my 2 fractions going to be? Okay, so we split it apart, which is great. Now the directions don't say simplify, so we'll come back to simplify it in just a second. Now, what I want you to try with your partners for a second is the same, that first step for number 2 and number 3, and then we'll come back together, trying to break apart number 2 and 3 in the same way. So I had a good question as I walked around. Don't write this down. Are you going to write this down?
No, sir. I promise.
The question was, is x with secant? Yes, just because there's not a parenthesis there, make sure they stay together. So we should have had this secant x plus tangent over secant x. Okay, that's what your answer should have been for number 2. Now for number 3, you should have had cotangent x over cosine minus 1 over cosine. Now, the directions aren't to simplify. I just said rewrite the fractions as the sum. This number 3, I am going to simplify it. When we start to simplify, a good first step is to turn everything into what's and what's. Cosines and sines. So we've only got one thing that's not cosine or sine, which is cotangent. Cotangent is the same thing as cosine x over sine of x because it's the reciprocal of tangent, right? So we've got cosine over sine, all divided by cosine, then a minus 1 over cosine. Now I'm trying to simplify this as much as I can.
Get rid of the cosine x from the bottoms.
What are you saying? Go like this?
Yeah, cancel.
Well, we can't do that yet because of the subtraction there.
Oh, so yeah. Same thing.
Yep, I'll keep that blue. I'll multiply by 1 over cosine because it's cosine over 1. So we've got the cosines are gone. We've got 1 over sine minus 1 over cosine. Gosh. Censor yourself while you're recording. So, almost fully simplified.
Secant minus cosecant.
Other way around, 50% correct. Great job.
Oh.
That would be cosecant minus secant. Final answer. On your paper from yesterday, you have 3 Pythagorean identities. The way you get them is you start with the basic one, which remember that stems from the fact in the unit circle that the y values are represented by sine and the x values are represented by cosine and the hypotenuse is 1. So by the Pythagorean theorem, you got sine squared plus cosine squared is 1. Okay. Now, is it a legal move? Don't do this to divide everything by 3. Mathematically, is that allowed?
Yes.
Yes, it is. So instead of that, because that's boring, I could do tangent, but that's not going to get us where we want to go. Well, maybe it would. I'm going to divide everything by sine squared just for funsies. Now, what's sine squared over sine squared? Just a 1, okay? So we've got 1 plus, what's cosine over sine? Cotangent. So that's 1 plus cotangent squared. And then 1 over sine squared is what?
Cosecant.
50%. Love it. Yes. Cosecant. So that is another Pythagorean identity. Okay. If I did sine in red, what do you think I'm going to do in purple?
Cosine.
Whatever you do to one thing, you just do to all of them?
So that's our little setup right there.
So if you want to put a red box around that other one, that comes up a lot. So this becomes tangent squared plus, what's cosine over cosine? 1, great job, equals secant squared. That is another Pythagorean identity. You don't have to have the red and the purple memorized. I would say if you have the black memorized, that's probably a good idea because you can get to the other ones if you had to. If you got to a situation where you had something like cotangent squared, what do you think cotangent squared would be equal to? Cosine squared over sine squared is legit, but if we're just using this red box right there, what if I said equals cosecant squared? There a 1 would have to be involved. So if I moved the 1 over, you might have to recognize a situation where they rewrite it like that. So what I'm trying to tell you is, if you see two things that are squared, you should probably be thinking it's talking about a Pythagorean identity. Okay? Same thing for the purple box. If I just gave you a 1 like this, using the purple, what is 1 also equal to? Tangent squared and secant squared on the same side, which would be secant squared x minus tangent squared x.